Hey guys, what's up? Welcome to for Physics by Inquiry. I'm just gonna do a recap of what we've done so far in case you had to miss out on something. So first week we started off. We did like community building. You guys learned about some careers in physics. You found out that like skateboarders can be physicists, and a lot of people have like interesting backgrounds. I'm trying to find a good light. I'm not really in a good light here. All of a sudden it's better. Anyway, so that was the first day. There's an activity I would highly encourage you to do. We also did an electric circuits pre-test. So basically, you did the pre-test on a separate sheet of paper, and you just submitted that to me through Google Classroom. Um, we did not do this journal, but you guys did meet your groups. We did note card expectations, and you guys lit a bulb. That was 1.1. So let's take a look at how the course operates. So if I look at the course, this is the stream. Um, Team expectations note cards. That's what we did today. So you guys met your group mates and you came up with some expectations. If there might be some tweaking for that. The other thing that you guys did was the pre-post test. So you just do the pre-post just answer these as best you can. It's a pre-test, so you don't have to worry about being right. These are just predictions, so it doesn't really matter. But you do want to make sure you try to answer all the questions, even if it makes no sense. Just try your best on that. Um, Okay, so for the most of this class, you guys are going to be looking at student materials. This is what we talk about when we talk about like the experiments. If you click on this, you will find that it has 1.1, 1.2. This part right here, after 1.4, it says discuss your definition with a staff member. Anytime you see that check, that's a checkpoint. That's what I'm looking for. So when you're working on this stuff, it's not about turning in work, but it's more about that discourse and having discussions and basically talking about what you've learned with me. So I will probably ask you when we do these checkpoints just to put your notebook in your camera or something like that to show understanding. Um, so that is part of your student materials. But wait a minute. This is talking about experiments and you don't have these materials at home. So we do have things for you, like here we have a circuit construction kit. Um, in this case, we are going to be making circuits for section 1. All you really need is a battery and a light bulb and a wire. And you're going to do some experiments with that. So just follow the student materials. I will include things on here that help you. So, um, so like later on, we see that we have for section 1, this is how do you adapt this to distance learning. So it helps if you actually look at the pictures of the bulbs. Ooh, look at the bulbs there. Notice that they have a threaded side and then they have that kind of a black thing, and then they have the end is also metallic. So you want to include all those in your pictures. So this is going to give you hints. So you can kind of work alongside with the student materials and the slides. The slides are here. They are also in electric circuits. Um, so the slides are, yeah, it's basically the same slideshow. And I basically go through and try to make concise slides that cover all the bases. If you want to know where you should be at, where the class is at, you can look at the pacing guide. All right. So what did we cover on the first couple days? Well, we covered. We did the pre-test. You did a game of science. Those were outside activities. Today, which is Wednesday, we met in groups. You guys did note card expectations, and we also did 1.1, which is lighting a bulb. We have norms of collaboration. These are things you can look at if you want to work well together. These are descriptions on how you what your note card was. I do have these are your groups. These have been changing kind of based on who's showing up and who works well together, who you're comfortable with. Groups should not be larger than 4 people. And so at the end of the day, I'll try to have exit directions that we can just copy post and put that in the chat. This is group work, so it is important that you're showing up, though. This is not a supplementary material. You can't just watch these things and learn. So what did we do today? Well, we looked at a bulb and a battery, and you should come up with 4 ways of lighting the bulb. How many parts, how many ways are there of lighting the bulb? So you can think of this as like the wire and the bulb. And the bulb really has like a bunch of different parts. The battery has a bunch of different parts. Battery has a positive side and a negative side. Positive side usually has the nub, and the negative side does not. And so in your notebooks, when you go through these things, make sure that you're recording these things. So this is one way that that lights the bulb. There are 3 more that you guys have to think about. Now let's look at this diagram carefully. What you notice is that it clearly marks the side of the bulb, the bottom of the bulb, and the battery. And so that's what we did for today. When you see the stop sign, that's where the class is at today. So for tomorrow, just a little bit of preview. Usually we start off with an attendance question. It's a way for me to see that you're there. We're going to talk a little bit about scientific explanations. 1.2 is, why do we call it a circuit? Why is it a suitable name for the battery and the bulb once it is lit? It asks you to look at flashlights. We have pictures of flashlights, and you're basically gonna look at like how a flashlight is designed, and these are just the handheld flashlights. These aren't the flashlights on your phone, but these are like the portable flashlights. And study this and think about, how is this a circuit? How is this a circuit? What are some requirements? So that's 1.3. And then we have operational definition. You're going to construct an operational definition. That's going to be kind of the tricky part. Operational definition, I should be able to listen to you and hear you, and with the materials, be able to construct a circuit. So characteristics of a good operational definition: they must be clear and concise, and everybody can follow them and make make a circuit. All right? So that's basically the first 2 weeks. I hope you guys enjoy yourselves, and see ya.